We'll now look into the amorphous forms. Amorphous forms we've already mentioned that it is charcoal, coke, lamp black and gas carbon. Now charcoal can be divided into three more types depending on the source: wood charcoal, bone charcoal or sugar charcoal. Now wood charcoal is the one that is used in household as a fuel for keeping us warm in winters, also for slow cooking. Then bone charcoal is going to remove colored impurities from sugar. The sugar that is present is colored and the sugar that comes into the market is not colored. So to remove the impurities, colored impurities from sugar, we are using bone charcoal. Then sugar charcoal is used as an adsorbent material. Sometimes instead of activated charcoal, there is also an activated charcoal. See, charcoal is basically known for its porosity. A lot of pores are present in it, and therefore charcoal can function as an adsorbing agent. So the adsorption means taking it on the surface, that is absorbing substances on the surface, that is called adsorption. So adsorption is a very common property of charcoal because of its porosity. And sugar is much better than bone charcoal because it can be used instead of activated charcoal for adsorbing certain substances. Now coke, as we mentioned previously, is used as a reducing agent in metallurgy to convert metal oxides into metal. For example, zinc oxide can turn into zinc. Similarly, ferrous oxide can turn into iron. Lamp black is used as a filler for the rubber tires. Rubber tires will become even more dense and harder and will get the color because of carbon. So it's a filler stabilizing the tire. Then gas carbon is used as electrodes in the dry cell. So like that we have different applications of the amorphous forms too, and wherever needed a particular allotrope of carbon is made use of, and because of its varied applications we again say that carbon has got extensive applications. We'll now see how wood charcoal is prepared. We'll take the shavings of wood in a test tube and then heat it using a Bunsen burner. And what all fumes come out of this enter into this conical flask, which is made to have a lower temperature by having a cold water beaker. Means this entire conical flask is placed in the beaker containing cold water, and what all fumes have gone into this, they'll all condense here to give wood, tar, charcoal, all those things, and the gaseous form that comes out of this, and suppose we light a matchstick here, it will burn the gas. That gas is wood gas. So from the wood shavings we are going to get wood tar, wood charcoal and then the wood gas. Wood gas burns directly when you place a matchstick, burnt matchstick, lighted matchstick, and the remaining part will form wood charcoal, wood tar and certain other impurities. So that way we make wood charcoal from wood shavings. From the wood we are going to release the gas and the remaining content is wood tar, charcoal and a few impurities. We have seen wood charcoal preparation. Now we'll see how bone charcoal and sugar charcoal is made. Bone charcoal is also called animal charcoal, and you start out with animal bones. Animal bones will have calcium phosphate and then the charcoal part, that is the coal part, on destructive distillation is going to give bone charcoal. Then sugar charcoal will come from sugar. This is cane sugar or sucrose. The cane sugar is dehydrated using H2SO4, sulfuric acid. Concentrated sulfuric acid will dehydrate this cane sugar, and this water, this is nothing but, shall we write 11H2O. So from removal of 11H2O we are left with carbon. So that is sugar charcoal. Next, how to enhance the activity of charcoal. Charcoal we said has got good amount of porosity. A lot of pores are there and therefore can function as a good adsorbing agent. Now, how to improve the adsorption ability of charcoal? This charcoal is subjected to a temperature of 900 to 1600 degrees Celsius in an atmosphere of either water vapor or simply vacuum, and then you get activated charcoal. Activated charcoal is an excellent adsorber of substances, and therefore charcoal can be improved in its efficiency of adsorbing things by making the pores much better, and this is done by heating it to a temperature in vacuum or in an atmosphere of water vapor. Looking at the properties of charcoal, the physical properties, as we have already mentioned, that charcoal has got good amount of porosity. It is black in color and large surface area. So this large surface area is responsible for its adsorbing action. So it can function as an adsorbent in removing coloring matter and then poisonous substances. For example, it can be used as a gas mask. So in the gas mask, it will adsorb all poisonous gases. And coming to chemical properties, charcoal is nothing but an allotrope of carbon. So what all carbon shows, charcoal also has to show. So carbon and oxygen will at a higher temperature react to form carbon dioxide. So these are all happening at a higher temperature. Similarly with sulfur, it forms carbon disulfide. Carbon disulfide is a good solvent, used as a good solvent for substances and certain substances. Then carbon with hydrogen will form methane. Methane, you know, is an excellent fuel, part of natural gas and CNG. Then reducing action. Now bone charcoal is not used as a reducer of substances because it has got good amount of calcium phosphate content, and therefore we'll use only wood charcoal or sugar charcoal. Now wood or sugar charcoal, because it is carbon, carbon can get oxidized. Once carbon gets oxidized, it can function as a reducing agent. So it is going to reduce steam to hydrogen by absorbing the oxygen part. Similarly from zinc oxide, it will make zinc absorbing the oxygen and turning into carbon monoxide. This is what is used in metallurgy for converting a metal oxide into a metal. So what you find is that charcoal can function as a reducing agent. Carbon monoxide is also a reducing agent, carbon is also a reducing agent, and it can also react with non-metals such as oxygen, sulfur and hydrogen to form their binary compounds.